Hello, my name is Nicole Martin. I am in lab section MO5 and this is my lab 7 black hole mass. In this lab, we have a star that is orbiting a black hole of unknown mass, and the net force acting on the problem is only caused by the gravitational force. The information given to us is the mass of the star, the position of the black hole, and the time it takes for the star to orbit the black hole. Our objective is to find the mass of the black hole. To do this, we will have to consider the parallel and perpendicular forces to find the net force. We will also have to rearrange Newton's law of gravitation and plug in our known values. And at the end of this lab, we will find that the mass of the black hole is 3.18 times 10 to the 31st. So if we look at our code, here we have 3 arrows, and these arrows will be representing the net force acting on the star, which is in black, and then the parallel force acting on the star will be in blue, and the perpendicular force acting on the star will be in red. So here we have the mass of our star and how long it's going to take for the star to orbit the black hole. Next, we put in the data that was given here from WebAssign, and that's just the position of the star at different times. And so next, we'll actually get into the physics of the problem. And first, we have to calculate our initial and final momentum, which will be the velocity of the black hole times the mass of the star. The momentum is the velocity of the star times the mass of the star. And next, we have to find the change in velocity and the change in momentum, which is final minus initial. So now we're going to get into our parallel and perpendicular forces. We know that the net force is equal to the change in momentum over the change in time. And so that's why we have this set up like that. So first, to find our parallel component of the net force, we know that dp dt parallel is equal to the change in the magnitude of the momentum times p hat. So that's why here we find p hat, which is the vector of the magnitude divided by the vector of the momentum divided by the magnitude of the momentum. And next, we have the magnitude, which is the change in the momentum over the time step, and putting that all together, we find the parallel component of our momentum, which is the change in the magnitude of the momentum over time times p hat. And we set our F net parallel to dp dt parallel. And for dp dt perpendicular, we just have to do F net minus the F net parallel, because we know that F net parallel plus F net perpendicular is equal to our net force. So subtracting that gives us our dp dt perpendicular, and we set our F net perpendicular to dp dt perpendicular. So here we have our arrow scales, so that our arrows will be represented. And the last alteration we have to make to our code is rearranging Newton's law of gravitation to find the black hole's mass. So we have the magnitude of the net force times the position vector squared divided by g times the star's mass. And so if we run the code, that's what we're given. We have Fnet parallel, Fnet perpendicular, and this is Fnet. And here is the mass of the black hole. So what does this mean? Discuss how Fnet and its parallel and perpendicular components are related to, as well as different from, momentum and its parallel and perpendicular components. Well, as I stated while we were looking at the code, we know that Fnet is equal to dp dt, so that also means that the parallel and perpendicular components of Fnet are equal to the parallel and perpendicular components of momentum. And essentially Fnet, this force, is what's causing the change in momentum. Imagine if the black hole whose mass you found was replaced by a different black hole but still placed at the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? In other words, is it possible for you to find a value for the mass of the black hole that is different from the mass you found for the original one? Essentially, yes, we would be able to find the mass of the black hole, because if it's placed in the same position, well then how we rearrange Newton's law of gravitation, that will be the only factor. Nothing's changing, so we would still be able to find the mass of the black hole. And that is the end of my lab.